You want to generate images with Stable Diffusion but don't know how to do it? Take it easy and let the AI genie introduce ComfyUI to you. Let's introduce ComfyUI. ComfyUI is an open source project that allows you to define with a UI some workflow that will help to generate easily images and video using generative AI. As I said, it's an open source project. It's very easy to use, and you can do astounding things, basically with Stable Diffusion models. If you go on the GitHub project, you see it's under a GPL3 license, and it's mainly developed in Python language. Right? Very easy. It runs on Windows, Linux, and Mac OS. On Windows, it's quite easy to install. You just have to download this file, zip file, ComfyUI Windows Portable, and as soon as you unzip it somewhere on your desktop, for instance here, you have here all the necessary files to run everything. You might have to download models, of course. Then I will run NVIDIA GPU batch file because I have a GPU installed on my laptop. And then you can see it's checking the version of Python, and then it starts everything and launch the graphical user interface here. So let's start with a very simple default generation model here, and I will explain the different boxes that we have here. So the first step and an important one of any workflow, obviously, is to load a model. All right, so loads a diffusion model, checkpoint. Diffusion model are used to denoise latents. So let's go into the different models. We have different kind of models. Basically, we're speaking about Stable Diffusion. Stable Diffusion, let's say, is the technique and the family of open models that you can use or you can fine-tune to fit your own needs. It exists in several versions, and there is a large community of people sharing fine-tuned version of models. For instance, here, if I go here on civit.ai, here you can see you have several models, and if I go here, for instance, oh no, this one is not a good idea, but whatever, then you can see that the base model is Stable Diffusion in version XL 1.0. So yes, if you go on a Stable Diffusion, you have several versions of the model. The most used by the community today are version 1.5 or fine-tuned models based on this version, and the version Stable Diffusion X large, so XL, SDXL, and all the fine-tuned models that you have. All right, so you can download the models and install them. Basically, it's files that you will install in your folders structure. You can use the manager extension that is very useful also to install custom nodes or to navigate models and install models very easily here. Right. Let's go with a very simple demonstration. Here, I'll take the version 1 prune anomaly model that comes by default with the zip file and the standard installation of ComfyUI. And then what I'll do, I'll generate an image. I want to generate an image of a girl doing yoga. So I have two different prompts. I have the positive prompt that lists all the features that I want to be in my final image, all right? And the negative prompt are all the features that I don't want to have, right? And what you can see here also is, if I zoom a little bit, right? You have some of the features that are between brackets or even double or triple brackets. It's the brackets represent the weight of the feature, all right? So I really insist on the fact that the girl has a blue yoga outfit, for instance, right? So those two clip prompts, you have to understand that behind that, it's also different models, clip models, that encode a text prompt into features of an image in the latent space. So what is a latent space? The latent space is a vectorial space where that's what Stable Diffusion use that represent the feature of an image. So the model won't deal with pixel per se. It will deal with a vectorial representation of the image. And then when the image is generated, it will decode the image into pixel. That's the VAE decode phase here. But let's go here. First, I have to load an empty latent page. I want to start with something, and you know, it's a completely noisy image, like the things you can see on the screen on TV when you don't have any signal, for instance. All right, here, let's say I want to generate the image of 324 and the square image, right? Here, you could also change the batch size, so generate more than one image each time I click on Q prompt, for instance. But let's go into the details of the case sampler. All right, the sampler is basically the mechanism, the algorithm that will generate the image in an iterative way. So you have several steps here. So by default, it's 20 here. You have the seed. The seed is linked to the latent image. So basically, it's a random noisy image that you use. But if you don't change anything and you keep the same seed with the same parameters and the same model will always generate the same image, because basically it's an algorithm that is rolled up and that generates the same image each time. All right, so let's fix the seed. So it means that for the next version, when I will run the workflow again, the seed will be the same. All right, so I can see the change and the impact of the other parameters, for instance, when I change things here. All right, the CFG is the classifier free guidance. Basically, it's how adherent the image will be to your prompt. All right, you have different kind of sampler. Let's use this one, DPM2, and you have different kind of scheduler also, and I use Keras because it's interesting one. All right, the denoise is the percentage of the image that will be modified by the global sampling and scheduling process. So because it's a latent image, I want 100% of the image to be changed, right? And here I have the VAA decode that is linked with my initial model, and that will translate the latent image that is generated after the sampling method, the sampling mechanism, into pixels and images that I want to watch and to see here, right? Okay, so now let's go and launch the workflow. So you see it loaded the model, loaded the positive and negative prompt, and here you can see the sampling that is going on here. You have the percentage of advancement here in the tab. All right, so it's going. So at each iteration, the image is less and less noisy and more adherent to the prompt. Well, we will see about that, right? Now we decode the image, and here what we get, right? So basically, yes, I have several girls doing yoga, kind of, but you see the image is kind of hallucinated, basically, right? So I could change here all the prompts and the parameters, but the things I want to demonstrate in this very first video is how to change also the model and see how the models, they were trained differently, and so they will generate different kind of images, right? So now let's change and select a fine-tuned version of Stable Diffusion 1.5. So Dream Shaper is a well-known fine-tuned model. So we don't change anything. I keep the same seed, and I just want to generate again a new image here. Right? So I can save the image, or I can preview the image. I can put the prefix here when I want to save the image. As I said, I could generate several images in one batch, but let's do it with one single image so we can see the difference between the different models. So here's the community-based fine-tuned version. Here you can see it's far better, even if you can't see the whole body and the hands and something about the foot here that is strange, but basically, yes, you have the girl. She has long hair, she has a blue yoga outfit, and she's kind of in a park, right? There's no yoga mat and stuff like that. Now let's move to the SD Excel version of Stable Diffusion and relaunch the workflow now to see the difference. It's just to illustrate, and I always keep the same seed, but you understood now what I want to demonstrate is how the model already impact the final image, right? Because they were trained on different kind of data set to do different kind of images, to generate different kind of images. So with same prompts and same configuration, what will SDXL generate for us? Decoding phase, and now we can see, okay, this one is far better. It's nice. She has longer blue yoga outfit. Something a little bit strange here with the feet, of course. But it's quite okay. So I could play again with the clip and all the parameters here, but let's take also a fine-tuned version of SDLX that is called Power Path Mix, and relaunch all the workflow to see the difference here. So as I said, I could change the CFG parameters, I could increase the number of steps, and I could change the sampling and scheduling algorithm, right? But for now, and for this last generation, for this very first introducing video of ComfyUI, I want to see what Power Path Mix is able to generate with my prompts. There we go. So you see, it's a different style because it's a fine-tuned version of SDLX that is more oriented maybe to digital arts. But the position is quite okay. It's not lotus pose though, but there is a lotus in the back, so you can guess that how it went. Maybe I will do a last randomized here. I'll do just for you to understand how it works also. So now I just randomized, so it's a brand new seed that is used now to generate the image, and I don't change. I like the Power Path Mix, but it's a little bit pity that the lotus pose was not taken into account, and you can see the yoga mat is here, right? So I could play with the CFG, with everything, put more brackets around the yoga mat, or about the fact that I want the lotus pose, or that kind of thing, right? So just same parameters, different seed, and here we are. All right, again, some strange things with the feet here. Hands are quite okay, but it's not really the lotus pose. She's definitely in a park, but she has a yoga mat, right? So that's it for now. Very short introduction to ComfyUI, and then with the upcoming video, I will deep dive into different components that I can add to my workflow to interfere and modify the way the images are generated. Bye-bye. And that's it for now. Keep making wishes, and maybe the GenAI's lamp will fulfill them. Stay tuned.